In a recent video, I demonstrated SolidFire's backup feature, which is built into the product. As a reminder to those who may have not watched, you pick a volume, select a backup target such as S3 compatible storage, and then enter destination details. In this case, I'll be using a NetApp storage grid S3 compatible storage, and there in the bucket you have a subdirectory with a unique per cluster name, and then below that there are volumes that we backed up in a previous run. So one thing that backing up from the UI does not allow us, in addition to being parallel, is that we also can provide a snapshot ID. I took two snapshots of this volume 167. One is called newer snap to make it easier to recognize. So I could add this feature also to allow you to take a snapshot before you kick off these jobs, so that when you run backup to S3, your backup is using the latest snapshot you took, so you can have quiesced snapshots copied to S3 storage. Now, this script, I wrote it in PowerShell. I have it running on Ubuntu Linux. You could use Windows as well. As a reminder, I created a bunch of volumes. You can see that volume names and IDs are slightly different. And like I said, the idea here is no matter how many volumes you have, you can decide on a number of jobs that you want to run in parallel. So I could have 40, but for the sake of a demo, I will use my script to throttle at 10. As a start, obviously I had 0, so I would dispatch 10 at the very beginning, and then as any of the jobs complete, I would dispatch the next job that would then be scheduled right away. So as long as I have unfinished or unscheduled jobs rather, I would schedule them promptly, and then once I have no longer additional jobs to submit, the number of jobs running would gradually drop and end at 0. So you can see right here, some of the jobs are at 40% complete. But you see complete, like in the CLI here, there is no volume ID. The reason is, as jobs finish, there is no volume ID to really look because nothing is running. We don't really need to care about that. I mean, main point is that jobs complete successfully, and if they don't, we report an error. And here, as jobs complete, we submit new ones. So you can see now some of them are 0, others are at 40 or 60 or whatever percent. At all times, we'll be running at 10 or close to 10, as you can see right here. So we had 7 for a while, then 8, 9, 10. Now we're at 10, but we are running out of new volumes to schedule. Now you will see as some of these complete, we will not schedule new ones because we are done with all of them. So now this will dwindle down to 0. As it does, our checks will complete and our script will exit. So we are done right here. Now, one thing that I did not like about this demo, but which is okay, I guess, is it does run quite quickly, so we don't have to wait for too long. Couple of minutes, we ran through these 20 volumes, but the reason it doesn't run really nicely is we have 2 peaks, once when we schedule the first 10 jobs, and then because all of the volumes are the same size and empty, they all kind of finish at the same time, so we have this delay while we are polling, and then we dispatch the next batch of 10, so it looks like there are 2 peaks. With many volumes and different sizes, you'll have this running much smoother and better, and once we're done, you can see our jobs or data is copied to a storage grid bucket.